Welcome to the next topic. In this topic, I am going to discuss about the dimension of grids and dimension of blocks. So far, you must have understood what is the meaning of grids and what is the meaning of blocks in NVIDIA GPUs. Again, a small recap. Grid is an arrangement of blocks and block is an arrangement of threads. So, first we have to see the grid dimension. So, blocks in a grid or arrangement of blocks in a grid can be in 1D, 2D or 3D. So, meaning is that blocks can be arranged in 1 dimension, 2 dimension or 3 dimension. So, let us see this figure first. You can see this yellow color box is representing the grid, and within that grid there is a green color blocks you can see here, where I have mentioned the number B0, B1, B2 and B3. These are the arrangement of blocks. This structure is representing 1D, arrangement of blocks in one direction. So, here I have chosen the direction is x. If you see, this is x direction, this is your y direction and this one is your z direction. So, here you can see that arrangement of blocks in only in x direction. So, you can say that there are 4 blocks in x direction. Similarly, if we look in this pink color of box, that is representing as a grid, and here as well some blocks are arranged in some form. So, this is in x direction. Blocks are not only arranged in x direction, but blocks are arranged in y direction as well. So, here you can see that the arrangement of blocks is in 2 dimension. Now, look at this figure. Here you can see that blocks are arranged in 3 dimensions. This is the x direction, blocks are arranged in y direction, and then the blocks are arranged in z direction. So, we have understood that in NVIDIA GPU architecture, the blocks in a grid can be arranged in 1 direction, 1 dimension, 2 dimension and 3 dimension. And each blocks can be represented by its coordinates. These coordinates you can represent in x, y, z. This x, y, z basically inform you the position of the block in that particular arrangement. So, look at here, if I see here what is the coordinates for this block, this is going to be 0, 0 and 0, these are coordinates for this. Similarly, if I look at here, the coordinates will be 1, 0 and so on for B3. Because my block is present at position in x direction, it is at position 1, and y and z there is no block. So, that is why this coordinate points will be 0 and 0. Now, come to the 2 dimension grid. In this grid, I can say that the coordinate point of x is 0, it is 1, it is 2, it is 3. coordinate points for y is 0, it is 1, and there is no z. So, z will be 0 in this part. So, what is the position of block 6 here? The position of block, I can say here it is 2, 1, 0, simple coordinate system. So, likewise this coordinates basically tells the position of each blocks, and you can apply this method in 3 dimension. So, here again if you want to calculate the unique ID of this B7 block, and you know that the x coordinate is 0, 1, 2 and 3, at y position it is 0 and 1, and because there are 3 blocks in z direction, so it is 0, 1 and 2, and you wanted to calculate the coordinate of B7. So, you can say that it is 1, B position is also, y position is also 1, and then z position is also 1. So, its position will be 1, 1, 1. Similarly, we calculate it for the block dimension. In block dimensions, you can say that the arrangement of threads in each block, and this arrangement of threads in each block can be in 1D, 2D and 3D, 1 dimension, 2 dimension and 3 dimension. You can see here this green color block is representing the block B, and within that yellow color box, and I have mentioned here T0 and T1. So, letter T is representing the thread. So, within the block the threads are arranged in 1 dimension. Similarly, it is a 2D block and threads are arranged in 2 dimensions. And this block you can see this is a 3 dimension, and threads are arranged in x direction, y direction as well as in z direction, and the same coordinate system is applied within a block on the threads as well. So, now we discuss about how to identify the dimensions and what is the indexes in terms of block indexes, in terms of thread indexes. If you see the CUDA programming model, so in CUDA programming model these variables are predefined, or you can say these are the built-in variables that are present in a programming model, in CUDA programming model. So, griddim.x will give you the information about number of blocks present in x direction. Similarly, griddim.y will give you the number of blocks in y direction, and griddim.z will return the number of blocks in z direction within a grid. Next is block IDX. So, block IDX, IDX is a word is indicating the index, and these 3 variables are used to identify the position of the block in the grid. So, block IDX will give you the position of the current block in x direction. Block IDX.y index returns the index of current block in y direction. Similarly, block IDX.z returns the current block in z direction within a grid. So, you can say that if you try for this block, you know that value of x is 1. So, this block IDX will return 1, block IDX, this position is for y is 0. So, block IDX dot y will give you here position 0, and if you see the block ID of IDX of z, it will give you the index is 0. So, with this 3 values you can identify what is the position of the block in the grid. So far we have understood that grid dim dot x, dot y and dot z, it returns the number of blocks in respective directions. Similarly, we have understood the block ID x dot x, y and z, they give the index or coordinate value of the block, of the current block within a grid, it tells the position of the block in the grid. Now, we know that within a block there are threads, and these threads as well can be arranged in 1 dimension, 2 dimension and 3 dimension. So, there are the variable which are present in CUDA programming model, block dim dot x, block dim dot y and block dim dot z. So, this predefined variables is written the number of threads in respective directions within a block. So, block dim dot x is telling you, give the information that number of threads in x direction within a block. Previous one, this was within a grid and this one was related to within a block. Similarly, block dim dot y returns the number of threads in y direction, and grid dim dot z represents the number of threads in z direction within a block. Now, we have identified the particular block. Suppose this is my B1 block, and this within this block threads are arranged in all 3 dimensions. So, I can say this value of x is 0, 1 and 2, value of y is here 0 and 1 and value of z is here 0, 1 and 2. So, now the next built in variable is thread IDX dot x is basically written the index or coordinate value of the thread in x direction within a block. Similarly, thread IDX dot y and thread IDX dot this should be z here. So, this should be z, thread IDX dot x dot z represent the index of thread in z direction within a block. So, suppose you want to calculate the position of T5 and you will apply within this particular block what is the position of the this particular thread. So, thread IDX will return 2, thread IDX dot y it will return 1 and thread IDX dot z it will return 0. So, with the help of these values you can identify what is the coordinate of this particular thread within a block. So, let us discuss 1D grid and 1D block. It is just to develop our understanding more in detail. So, this arrangement is representing 1D, this is a grid, 1D grid. So, here is only one block. So, that is by default it is become a 1D grid, and if within this block you can see that threads are arranged in only in x direction. So, that is the reason it has become 1D block. Now, look at this figure. What we say? Here again Blocks are arranged in x direction, and within the each block the threads are also arranged in x direction, if you see. So, that means it is also a 1D grade 1D block. So, let us calculate the global thread ID for 1D grade 1D block. I have chosen the direction is x. You can take it in y direction, or somebody can take it in z direction only. So, let us see, this is the arrangement of blocks in x direction, and you can see the yellow color boxes, that is the thread coordinates. It is giving you in x y direction I have taken. Similarly, the blocks coordinates I have mentioned here. So, first of all I want to calculate the number of threads present in this entire arrangement. By look at, you can see that each block has 3 threads. So, total is 9 threads. But how we can calculate that? So, first of all you have to find out the grid dimension, and then you have to find out the block dimension. How you can find out these values? So, I think you are aware of that. You know the parameter block dim dot x, I am just writing in short, dot y and dot z. When you see that block dim dot x, that is basically calculating the number of threads within a block. So, in x direction, if you see that there are 3 threads here, you can see that these are the 3 threads in x direction. So, this value is 3. If you see, there are no blocks in, there is no threads within a block in z direction and y direction. So, but you cannot make it 0, you have to consider it as a 1. So, when you multiply all these 3, block dim dot x multiplied by, I am just writing in short, dot y, I am just writing in short like b dot y and b dot z. So, here you can put the values 3 into 1 into 1. So, you will get the answer is 3. Yes, there are 3 blocks. So, keep remember, whenever you are counting the number of, because number of threads or number of blocks. So, even though there is nothing in y direction and z directions, but by default any position, any value is there, that means something is there in x direction and y direction. So, by default values are 1 and 1. So, now we have to calculate the block grid dimension. So, for the grid dimension you have the values grid dim dot x, dot y and dot z. So, in x direction there are 3 blocks, and in y direction and z direction there is no blocks. So, by default value is 1. If you multiply all these 3 parameters, you will get the answer is 3. So, you can say that the total value of 3 into 3 is equal to 9. So, here in this arrangement I came to know that how many blocks are there and how many threads are there. So, total number of threads I came to know is 9. When I see that visually, so you can say that there are 9 threads. So, you can apply this on different arrangement. You can add one more block here, or you can add one more thread within a block here, and you can verify this results. Now, let us calculate the block global thread ID. and why it is important to calculate. I just give you a small example. Suppose you want to transfer, you have some array, an array has value 2, 3, 4 and 5, or you can take more values 6, 7 and 8 is the array, and you wanted this array, I am saying A, array is A. So, what you have passed, suppose you want to make a array B and you have given the value third idx dot x is equal to, you can say again third idx dot x, and you are adding some value 1 to it. What will happen in this case? Because you know that thread idx is a value of each individual thread within a block. Here thread id is also same. Here in this block is different, but thread id is same. In this block thread id is same. So, that means when you launch this thread in terms of 2 blocks, every time you are getting the value, and it is this value 0 0 0 0 0 0 and 0 0 0. So, you can say that is idx in x direction, it is 0, it is always point only one variable. You can say that it always point you 2, and it will always point you 3, and it is always point you 4. So, that is the reason you are not able to get the exact answer what you are expecting. You want that entire variable should be added by 1 1 1. It is not going to perform here because of each thread has the same ID within a block. So, threads will get confused because every time the threads will be launched, it always go to this location, and this location has this value is 2 in this case. So, whether it is a block 1 or block 2, always they will fetch only one value 2. So, because of that you always get only 3 items will be processed, the first 3 items will be processed by the 2 blocks, remaining will not be processed. How to overcome that? To overcome that, to overcome all this, so we need to calculate the global thread ID. So, let us see how we can calculate that. The formula is in front of you. First of all, you need a block ID because this is arranged in x direction. So, first of all you have to calculate the block dot x. So, block ID in x direction is, suppose it is 0, it should be multiplied by the block dimension in x direction. So, you can say the block dimension in x direction is 3 plus block dimension thread idx in x direction in that particular block. So, let us calculate for this. Suppose I am calculating the block ID is 0 0 0, and within that the thread ID is this 0 0 0. So, block ID is 0. So, it is 0 I have taken, it is multiplied by the value 3 which is giving, which I got from this grid dot x is equal to 3, and plus I have added the thread idx because my thread idx in x direction it is also 0. So, when I have computed this, I will get the answer is 0. Now, consider the next block 1 comma 0 0. These are the coordinates. I have taken the second block as per this diagram. and this block also has the 3 threads which have the same coordinates, but how I can calculate its unique value? So, just think of it, the block IDX in x direction is 1. So, I have considered it here 1, you can see here. I know the number of blocks in x direction, so grid dim dot x value is 3. So, I multiplied by 3 plus, then I wanted to calculate this particular thread, you can see this thread. So, thread IDX of this thread in x direction is 1. So, I have added is 1. So, I got the value as 4. So, if you compute all these values, you will get here 1, 2, 3, so 4, 6, 7 and 8. So, basically it is giving you the unique ID of each thread, and when I will want to process some computation just like I have taken in previous example. So, what I will take here B, I will just giving the global ID in short is equal to A GID plus 1. So, every time it will go to the index, it will calculate the global ID of thread. If this thread has a each element present in an array, that will be added, and it will be some will be stored in its respective global ID. So, this is a way the global ID index play the important role in computation, and each thread will work independently on each element. So, that is the advantage of calculating the global thread ID. So far we have seen the global thread ID calculation for 1D grid and 1D block arrangements. So, this arrangement is suitable if your blocks are arranged in only in y direction or in z direction or in x direction, and within a thread also arranged in only in same direction. Suppose your blocks are arranged in y direction and your threads are also arranged in y direction. So, this formula will work for you, only the one changes you have to do, instead of x you have to consider y, every x to be replaced with y. If it is z direction, so then it should be replaced, this x should be replaced with z direction, because your arrangements are in z direction. So, similarly, in next part I will discuss about how to calculate and what are the challenges when calculating the global thread ID in multiple directions. Means grids may be arranged in one dimension, but blocks are in multiple direction. Blocks are in multiple direction, a grid in one dimension. In that scenario, whether the same formula will work or not, we will try to understand that, and we will see what is the unique formula we can develop to avoid this 1D or 2D or 3D challenges, etc. Thank you.